I am discussing about the what are the fundamental topics belong to the AC systems. What are the basic definitions in single phase AC system? In that, first of all, what is instantaneous value? That is the value of alternating quantity, the value of alternating quantity at any instant, at particular instant. Instant means time. At particular instant, that value is called the instantaneous value of the corresponding given waveform. That is, for example, a single AC waveform we are taking here. This waveform is voltage waveform and x-axis is time. Then here, this is the value of given waveform. This dot is value of the given waveform at time t1, and this is the value of given waveform at time t2, and so on. Here the values of E1 and E2 are called instantaneous values. Instantaneous values of the given waveform. By combining all instantaneous value from time to time, then you will get the complete waveform of the given alternating quantity. What is mean by alternating quantity? That is the value which will be alternating changes. That is at some instance the value is positive, and at some instant the value is negative. That is alternatively it becomes positive negative positive negative. Okay, that is called the alternating quantity. Then here in this for example, E1 and E2 are called the instantaneous values at the instance T1 and T2. Okay, like that, by combining all the instantaneous, you will get the exact alternating quantity. Then the second is, what is waveform? Waveform is nothing but a graph which is obtained by adding all the values of instantaneous values. That is, after getting all instantaneous value at every time, then by adding from time to time, that is t1 t2 t3 t4 like that, adding all instantaneous values e1 e2 e3 e4 like that, then you will get the complete waveform. That graph, that is called the complete waveform after adding all instantaneous values. Okay, this is the a complete waveform. Okay, in the waveform, the positive values are called the positive off cycle, and the negative values are called the negative off cycle. Okay, in this way, we will get the waveform. Then after that, what is mean by cycle? Cycle means a continuously repetition of positive and negative off cycles. Okay, that is called the cycle. That means, for example, here I am drawing one waveform. This is one cycle, positive, negative. Again, positive and negative. This is another cycle. Then here, this is called cycle 1. From this is called cycle 2. Okay. In this example, we have number of cycles equal to 2. Suppose we can drawing extra cycle also, only having positive. Then here, only half of the waveform will be obtained. Then total number of cycles is nothing but 2.5. That is first cycle, second cycle, and third cycle will be only 0.5. Half of the cycle will be obtained. Then by combining number of cycles equal to 2.5. Like that, we are calculate number of cycles in the given waveform. Then what is meant by periodic waveform? That is, if the waveform repeatedly obtain the same positive and negative, again positive and negative, that means here we can take it as time period t here. Then again after time period t, the same waveform, before waveform, the same will be repeated, same exactly positive and exactly negative. And here also again the same positive and negative will be repeated like that. Then that waveform is called the periodic waveform. That is, definition is f of t equal to f of t plus t. That is, the same function or the same waveform will be repeated at every time instant capital T. Okay, that is, here after time period T, the same waveform will be repeated like positive, negative. Then that period is called the periodic waveform. Okay, here this is also called cycle. This cycle, a complete combination of positive off cycle and negative off cycle is called the one cycle. And next one is, what is mean by time period? That is, here the time taken to complete one cycle, that is called the time period of the given waveform. Okay, how to calculate the time period for the given waveform? That is, after giving the waveform like that here, suppose the voltage is waveform V. Here, where is one cycle here? This is the one cycle or first cycle. That means here we are taking as time is capital T. That is, the time taken to complete one cycle. That time period is called the, that is the time period of the given waveform. Okay, that time is called time period. After that, the same waveform will be repeated. Then that is called the periodic waveform. Okay. For example, here I am showing here example waveform. This is the waveform here. Only positive cycle. Here the angle is 90 and this is 180. Here what is time period here? That is 90. Here only complete one cycle. Only positive cycle is there. That's why up to positive cycle the time period is 90. Suppose for example the time taken to complete cycle here, for example, this is 10. Then the time period is 10 here. Okay. In this example, we have both positive and negative half cycle. But in first example, we have only positive half cycle. So that is, this is positive, this is positive. That means only the first is called positive half cycle, again positive half cycle. Okay. Then the time taken to complete one cycle, nothing but time period. That's why here we taken as 90 is the time period of the that given waveform. So like that, we have to calculate the time period for the given waveform in the problems. Then, what is mean by frequency? Then, generally the frequency term will be obtained in AC systems. That is, you have to find out the frequency is number of cycles per second. Okay, that is called the frequency. In another words, the frequency is the reciprocal of time period. If you know the value of time period, then easily you can calculate the value of frequency. Okay, that is, for example, here I am showing this time period T, we have only one cycle. Again, the same time period we have having two cycles. Okay, this is in the time period t. In this example we have one cycle only. In this example, the same time period t, we have two cycles only. Okay, the same here in the first problem, here we have low value of frequency and we have high value of frequency. That is, in the first example, we have only one cycle. The second example, we have only two cycles. That is, cycles is increasing. Then number of cycles are increasing. Then you will get the frequency is more. So like that, you have to calculate the frequency value based on the number of cycles here. That is the frequency value and amplitude or peak value. That is, the definition of amplitude or peak value is it is the maximum value of the given alternating quantity in positive and negative of cycles. That is called the maximum value or peak value. So that is generally, for example, taken as voltage waveform here. This is called the peak voltage. You can denote Vm. And for negative of cycle also, that is maximum value, this will be shown as minus Vm. Okay, the value of maximum value is same, that is the magnitude is same, but change is the sign. If you take in as positive values, it is taken as plus Vm. If you take in as for negative peak values, that is taken as minus Vm. Okay. For example, simple problem is there, then here taken as 10. Then therefore the Vm, the maximum value, you can denote it by Vm. It is, suppose the waveform given is voltage waveform, you can take it as Vm. If the given waveform is current waveform, you can take it as Im. Okay, whatever the function value given on the y-axis, then you can take it as Vm, Im, like that. Then here in the example, the Vm value is 10. That is called maximum value of the given waveform. In this way, you have to calculate what is the peak value for the given waveform. That is the Vm. Then after that, what is angular frequency? That means the frequency you can represent in radians, electrical radians. That means the angular frequency you have to denote it the number of cycles. That is the 2 pi radians in number of cycles. That is 2 pi f or 2 pi by t. F equal to 1 by t. We know that. Like that, you have to calculate the value of angular frequency. The formula is omega equal to 2 pi f or 2 pi t. That is, it can be represented in electrical radians. That is the representation of electrical radians of frequency. That is called angular frequency. That is omega equal to 2 pi f. After that, what is mean by peak to peak value? Okay, this value calculation of peak to peak value is very important. That means the total value or the distance from positive peak to the negative peak in the given waveform. The distance or the length or the maximum values from peak to peak, that is the positive peak to the negative peak, that is called the peak to peak value. Okay, in this example, I am taking as 4 volts positive and similarly 4 volts for negative. Then the peak to peak value, that is 4 plus 4, that is total will get 8 volts. Okay, that means this total distance positive peak to the negative peak, that total distance we are calculating as peak to peak value. Okay, after getting the waveform, after giving the waveform in the problem, then we have to calculate peak to peak value like this. So you can calculate the length from positive peak value to the negative peak value. That total length is called the peak to peak value, or adding positive peak value or negative peak value. Okay, in this problem, the positive peak value is 4. The negative peak value is minus 4. That is 4 minus half minus 4. Nothing but adding 4 plus 4. Will total will get total distance from positive peak to the negative peak is 8 volts. In this way, you have to calculate peak to peak value also. Then after that, generally the single phase AC system you have to represent is, that is, Vm sin t in terms of time, or in sum of theta, that is Vm sin theta, or in terms of x-axis is omega t, that is V of omega t equal to Vm sin omega t. So like that, you can write down the equations of single phase AC waveform. In a sine waveform, then what are the variable given on the x-axis? Then you have to write down the sine term and x-axis variable, sine t, sine theta, or sine omega t, like that. Okay. Then generally, how to write down the complete AC waveform? How to represent? That is, here we have to represent the AC waveform is, in general, AC waveform, positive value and negative value like that, and positive and negative like that here. Okay. Then here this will be obtained 0 degrees, and the maximum value will be obtained at 90 degrees. Again the 0 will be obtained 180 degrees. Again negative peak value will be obtained to 70 degrees. Again 0 will be obtained at 360 degrees. That means this is angle pi and this is angle 2 pi. Okay. At every 2 pi, the same positive and negative sine waveforms will be repeated again. That's why you write down the complete angle is, to write down the sine waveform is up to 2 pi radians. Okay. In this way, generally you can write down the sine waveform. Then I am showing you how to calculate the basic definitions we can discuss above. That is the, for example, I am taking a single waveform, AC waveform. I am showing in this waveform, in this example, how to calculate peak value or peak to peak value, time period, frequency, number of cycles, so like that. How to calculate after giving the waveform in the problem. Any waveform, sine waveform or square waveform, triangular, any waveform. Here, this is called maximum voltage, and this is called maximum negative voltage. Then the times are 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. Okay, here. Then in this waveform, how to calculate the values are, that is, first of all, how to calculate time period, that is t. Already we know what is the definition of time period. The time taken to complete one cycle. So this is the one cycle, means up to this and up to this. This is called one cycle. The repetition of positive and negative. That's why the time period t is nothing but 0.4 seconds. Then immediately we know time period, then immediately you can find out the frequency of the AC waveform, nothing but 1 by t. Then that is 1 by 0.4, that is a hertz. The units of frequency is hertz, we know that. Then From that waveform, what is peak to peak value? That is VPP, peak to peak. So that means positive peak value is 8 and up to negative peak value is 8. Then what is the total distance from positive to negative peak? That is 8 plus 8. Then peak to peak value is 16. Okay. Then similarly, after finding the frequency f value, then you have to find out omega, that is angular frequency, that is 2 pi f. Then 2 pi into f nothing but 1 by 0.4. Then like that, you have to calculate the value of angular frequency. Then suppose what is the instant value at 0.3? That is, you have to calculate instantaneous value at 0.3. Then the given waveform, where is the 0.3 value? That is, the 0.3 is the middle term here. Okay, this middle term at 0.3, the value is maximum. But it is a negative peak value. That's why the value is minus 8 or minus 8 volts. Similarly, what is the instant value at 0.6? That means 0.6 is here. Okay, this is the 0.6 time period. Then at 0.6, at this value, the value will be 0. That's why the instant value at 0.6 will be 0. Then similarly, what is the amplitude? That is maximum value. Vm equal to in the problem given 8. The maximum value is 8 volts. Okay, like that, you have to find out any value from the given AC voltage waveform or AC current waveform. Simply sine waveform. Okay, then after that, what are the basic different AC waveforms generally we are using here? That is, the first one is most of the AC waveforms we are using sine. And in the problems also, the problems are given, that is square. This waveform is square and this waveform is sine waveform. Or we are also having this is called triangular. Triangular waveform. Or in the problems, most of the problems the waveforms also given, the most important waveform is, that is the, this is called sawtooth waveform. So the same waveform you can also write down like this. So these are the different waveforms generally asking to find out the what is the average value of the waveform as well as what is the RMS value of the waveform. Okay, the most important problems in university examinations is to find out the average value, RMS value for the given waveform, either sine wave, triangular, square, any waveform is given. And one of the most important waveform also given in examination, that is the trapezoidal. So this waveform is called the trapezoidal waveform. Okay, na? Then you must know about the how to calculate the average value, RMS value for the waveform. That is, you have to find out what is the formula for average value and what is the formula for RMS value. So like that, we have to find out all quantities for the given AC waveform in problems. Please subscribe our channel and share to your friends.